Lesson 57, the ideal gas law. When working with the ideal gas law, these are word problems, and we're going to have to use ratios and ratios in the form of equations to solve. The nice thing about these problems is there's a formula that we are going to use in order to solve these. And the formula for the general ideal gas law equation is P1 V1 over T1 equals P2 V2 over T2. That is the equation. P1 V1 over T1 equals P2 V2 over T2. Now let's talk about what P, V, and T mean. When we talk about P, we're talking about pressure. Those of you who have taken physical science or chemistry, you've seen this before. P is pressure. Pressure can be measured in different units. I'm going to give you some of those units so that when we read the word problems, you know kind of what to look for in terms of pressure. Pressure can be measured in atmospheres. Okay, it is abbreviated ATM. Okay, that's an atmosphere. Can be measured in atmospheres. Can be measured in millimeters of mercury. Okay, it can be measured in torr, and it can be also measured in pounds per cubic inch, or pounds per inch cubic. So those are different ways that we would measure pressure: in atmospheres, millimeters of mercury, torr, or pounds per cubic inch. V stands for volume. The most common ways that we would see volume measured is in liters, milliliters, and we also see it in cubic centimeters as well. All right, so P is pressure, V is volume, and T is temperature. In the ideal gas law, we only use the Kelvin scale for temperature. We don't use Celsius or Fahrenheit, so they will either give you the Kelvin degrees, or if you're looking for temperature, the label will always be in Kelvin, because in the ideal gas law, temperature can only be measured in Kelvin. All right, so on your example sheet, there's 3 examples. We're going to look at the first example, keeping in mind that we are going to use this equation, P1 V1 over T1 equals P2 V2 over T2. All right, so let's look at the example sheet. Number 1. Number 1 says 4 liters of an ideal gas at a temperature of 800 Kelvin has a pressure of 100 newtons per square meter. If the volume were increased to 10 liters and the temperature reduced to 600 Kelvin, what would the pressure be? All right, so automatically we know we're going to use the formula P1 V1 over T1 equals P2 V2 over T2. So we need to look and determine what are pressures, what are volumes, what are temperatures, and which ones will I use for 1 and which ones will I use for 2. All right, let's look for P1 V1 T1, see if we can find some of these. All right, well, we have 4 liters of an ideal gas. 4 liters is going to be our V1. Okay, liters is a unit of volume, so V1 is going to be 4 liters. All right, so we have 4 liters of gas at an ideal temperature of 800 Kelvin. All right, so T1 then is going to be 800 Kelvin. Had a pressure of 100 newtons per square meter. Okay, a pressure of 100 newtons per square meter, so 100 is going to be our P1. All right, so right away we know our V1, T1, P1. So we know that we're going to be solving for one of the variables on the other side of the equation. All right, so let's go ahead and plug this information in first. P1, V1, so we're multiplying 100 times 4, and we're going to divide that by 800. Okay? Now we want to know what our P2, V2, and T2 are. So we keep on looking. The volume were increased. So we have a new volume that's going to be 10 liters. So our P2 is, our V2 is going to be 10. All right, so the volume was increased to 10 liters. The temperature was reduced to 600 Kelvin. So our new temperature is 600 Kelvin. and it's asking us to find what the pressure would be. All right, so we're looking for P2. All right, so on the other side of our equation, we're setting it equal to P2, which we do not know, so I'll replace it with an X, times V2, which is 10, divided by 600. Okay, once we get everything set up in the equation, you'll notice that it looks like a ratio. One ratio equal to another ratio, which is a proportion. So what we're going to do in order to solve is cross multiply and divide. So we're going to multiply 100 times 4 times 600. And in order to solve for x, we're going to divide it by 800 times 10. And this is really nice because all you have to do is plug that information into your calculator. When we multiply it out, x is going to be equal to 30. Now we need to label our answers. Notice in the first one it has a pressure of 100 newtons per square meter. Okay, so we're going to label this. You can either write out newtons per square meter. The abbreviation is N per meter squared. All right, so that is our new pressure. All right, let's go ahead and do this second example together. If you'll look at the second problem on your example sheet. Number 2 says, the initial pressure of a quantity of an ideal gas was 400 newtons per square meter, and the initial temperature was 1,200 Kelvin. The volume was constant. What was the pressure if the temperature was decreased to 900 Kelvin? Now, if we ever in a problem see where the volume was held constant, that means that one volume is equal to the other volume. Well, if I have volumes that are equal, we don't even have to include them in our equation because it's not going to change the result. So instead of using the formula P1 V1 over T1 equals P2 V2 over T2, since my volumes are going to be constant, they're equal, I don't even need to include volume in my formula. So now I'm going to have P1 over T1 equals P2 over V2. All right, so if we're looking for pressure 1, the initial pressure was 400 newtons. So P1 is going to be equal to 400. The initial temperature, which is going to be our T1, was 1,200 Kelvin. The volume was constant, okay, so we already took care of the volume. What was the pressure? So we're looking for P2 if the temperature was decreased to 900. So now we're just going to plug it into our equation. We now have P1 over T1, so we have 400 over 1,200, and that's going to be equal to P2, which we do not know, over T2, which is 900. Again, we have a nice little proportion set up, so all we're going to do is multiply, cross multiply, and divide to solve for x. So we're going to multiply 400 times 900, and we're going to divide it by 1,200 to solve for x. Again, we just plug it into our calculator, and we're going to see that P is equal to 300. Again, we need to label it, and it says pressure was given in newtons per square meter. Okay, so we can either write it out or use our abbreviation N divided by M squared. And that is the final answer. Using the ideal gas law formula, go ahead and do example 3 on your own, and we will check it in class.